tuntuma chuan crystal field theory chungchang kan lo en ho dona crystal field theory was first introduced by crystal field theory. Crystal field theory was first introduced by H. Bett and V. Black. Chuan crystal field theory le ama khan valence bond theory kan ena a in an lo na chu valence bond theory a kha chuan metal kha Lewis acid ania ligands kha Lewis base ani electron apia chuan an inkara khan coordinate bond a form ani mo electron acceptor electron donor forming coordinate bond kan ti kha ama ro chu crystal field theory a chuan d orbital sa khan d orbital sa electrons le incoming ligands inkara electrons sa khan d orbitals le ligands te electrons inkara khan repulsion alo om ta ni chu wang chuan crystal field theory chu it arises due to inter-electrostatic interaction between the metal and the ligand kan ti thayang chuan heta hian crystal field theory a chuan d orbital electrons se le ligands a inkara khan repulsion ion repulsion alo om ta ni chuan d orbital a chu d a khan 5 orbitals om kan ti kha orbital panga om ta chung orbital te chu dxy dyz dzx dx square y square le dz square orbital panga kan nei ta ni dxy dyz dzx dx square y square le dz square hi lo ni ta ni chuan hetia an om pa nga yan om hian degenerate orbitals an ni ta ni degenerate orbitals om zia chu having the same energy inang vek an lo nei ta ni ama ro chu ligands khan arzu approach ta ligands ina azu approach tak khan crystal field theory a chuan ligands in a approach khan repulsion alo om ta ni mo ama ro chu heta d orbitals panga te hian orientations in ang lo vek khan nei awang khan ligands direction lam pangami te kha a repel na sadona ni chuan ligands direction lo lamami te kha a repel na salo dona mo chu wang chuan panga theu a khan degenerate d orbitals an ni lai orbitals panga te kha repulsion kha in ang lo dona ni ligands ne na repulsion kha chuan crystal field splitting alo om ta ni chu tuna kan en tur hi octahedral field a bi kan ta ni crystal field splitting in octahedral field hei hi 5 degenerate d orbitals te khan ni ta ni degenerate om zia chu having same energy kan ti kha mo degenerate d orbitals an ni a chuan ligands ina azu approach khan they will be raised to higher energy level a chhota ni chuan heta tak hian repulsion kha orbital pangazinga khan a inang lo ta ni orbitals khan a chan chu orientation in ang lo vek an nei awang khan those in the direction of the ligands will be repelled more tin ta ni chumi ni om zia chu hemi amasa pathum hi T2G set an ni ta a anu nung pani hi EG set an ni ta ni hemi T2G set hi hian repulsion kha atlem zo khanga EG set a hian repulsion kha atam zok don ni chu wang chuan splitting alo om khan T2G set kha anwai an omanga EG set kha achunga an omdon ani. Mo EG set a khan orbital pahnih omanga T2G set a khan orbital pathum omdon ni. Chuan hei hi dxy dyz le dzx orbital te khan dia hei hi dx square y square le dz square orbital te khan ni ta ni. So it splits into two sets. Set pahnia lo intender ta a chuan hela inkar energy difference hemi inkar in thlauna hi delta O alo ni ta ni. Hei hi nakina kan soi fianga. Hei hi crystal field splitting chu ni ta ni octahedral field ta mo. So crystal field splitting omzia chu the splitting of 5 degenerate d orbitals into two sets of different orbitals into two sets having different energy in the presence of ligands. Alright, so we can say that crystal field splitting is the splitting of 5 degenerate d orbitals into two sets having different energies in the presence of incoming ligands. Ligands in a 5d orbitals panga energy in ang lava a split darakha crystal field splitting omzia chu ania, and this forms the basis of crystal field theory. So this is the diagram for crystal field splitting in octahedral field. Splitting of d orbitals in octahedral field. So anita hey here 5 degenerate d orbitals kania on the approach of the incoming ligand. It is raised to higher energy level and then splits into two sets, one having higher energy than the other. Chuan helaya hian an inkar hi delta O. O stands for octahedral. Mo octahedral ania delta O hi crystal field splitting energy. Crystal field splitting energy anitani. Chuan crystal field splitting energy hi factor sang khan atidang lam thaya chu kan enanga. This forms the basis of crystal field theory. The conversion of 5 degenerate d orbitals of the metal ion into different sets of orbitals having different energies in the presence of electrical field of ligands is called crystal field splitting. Chuan delta O kha crystal field splitting energy kan ti kha inkar energy difference inkar kha hei factor function in effect ani. The different factors which affect this crystal field splitting energy are: number 1, oxidation state of the central metal ion. Oxidation state of central metal ion. Central metal ion kha oxidation state asan po le crystal field splitting kha nasanga delta O value ki asang donani. So higher is the oxidation state, greater is the splitting. And then larger is the value of crystal field splitting energy. Alright. Chuan number 2 na chuan geometry kha poi mole ta ni. Geometry of the molecule. Chuan geometry kha chinhia om thei kan ti kha octahedral le tetrahedral geometry a om theya. Tuna diagram kan en khachu splitting in octahedral field kan ti kha. Chuan octahedral field ta khan splitting kha alian zok don ni anasa thei zok don ta ni helai splitting of the d orbitals splitting is more chuan splitting kha alen po le crystal field CAFSE value hi asang don ani chuan tetrahedral a chuan splitting is less more delta O value kha ate zok don ti na ni chu chuan number 3 na chuan number 3 na chuan size of d orbital kha poimo le ta a size of d orbital larger is the size of the d orbital greater is the splitting more larger d orbital greater splitting hi a factor poimo le deuh chu ni ta ni chuan greater splitting ani reng kha chuan larger value of delta O ani zel don ani chu mo inkar kha zau zel don ani chu all right chuan oxidation state of central metal ion geometry of the molecule le size of the orbital te kha apoimo ma delta O value factors determine tu te kha an ni ta ni chuan number 4 na chuan nature of ligands alo om le ta he hi apoimo ma ligands kha ni china kan soitong khan strong ligands le weak ligands om ta ni strong ligands example a chuan CN ang te kha mo CN chuan valence bond theory kan soitong khan it forces the electrons to pair up kan ti kha chuan strong field ligands le weak field ligands anom ta strong field ligands reng chuan they will cause greater degree of splitting larger splitting and then hence greater value of delta O and the weak field ligands will cause smaller splitting and hence lesser value of delta O. More. Strong field ligands reng chuan splitting khan cause na sa nga chu wang chuan delta O kha alian zel anga value kha in the presence of strong field ligands. However, in the presence of weak field ligands, there will be smaller splitting and hence lesser value of delta O. Chuan strong field ligands le weak field ligands te chu engtin nge kan share shanang kan ti chuan spectrochemical series kha apoimo ta ni spectrochemical series kha kan thiam nge ngai ta ni chu enge spectrochemical series kan ti chuan it is the arrangement of ligands in increasing order of strength. In increasing order of strength. Spectrochemical series is the arrangement of ligands in increasing order of strength. Ligands te kha achak dan in dota kan rem na series khami kha a order kha spectrochemical series chuni chuan halogens ho halides ho kha halide ions ho kha weak ligands an ni mon hei series chu atlang pui karon zia kanga He spectrochemical series in rem dan tlang pui chu ni tani hemi lo po hi lom chewa he example a karon ziak tani halide ions how he heng lam pangami hi weak field ligands an ni mo weak field ligands an ni awang khan crystal field splitting and cause khan splitting kha azim don ani an chak tok lo awang khan ama ro chu he lam pangami how he strong field ligands an ni awang khan they will cause greater degree of splitting ka and cause na sa theta a chuwang chuan strong field ligands a om reng kha chuan delta O value kha azau don ani chu alian don ani chu. All right, so the nature of ligands is very important in determining the delta O value, the magnitude of delta O value. All right, chuan crystal field splitting theory kha application kan endon ni heta hian compound panhi karon data henga hian unpaired electrons kha engzange omti crystal field theory mang hian kan zong chuak don ani pakhan na chuan FeCN64- ion kan lo nei ta heta hian central metal chu iron ani a electronic configuration chu 3d64s2 ania chuan heta hian iron hi it is in +2 oxidation state chumiam zia chu it involves the loss of 2 electrons alo ni le awangin 4s2 atangin electron panhi kan remove a 3d6 alo ni ta ni chuan d a khan orbital kha panga alo oma mo 5 orbitals om ta ni chuan iron Fe2+ hi 3d6 ani awangin electrons kha d a hian paruk kan fill up theitina ania 1 2 3 4 5 6 Hans rule mang zel khan mo the electrons are singly filled first and then pairing takes place ani kha chuan heta hian crystal field splitting kha alo om ta ni they will be raised to higher energy level and then split. Anwaya pathum ma oma T2G seta khan achunga EG seta khan pahnia om kan ti kha chuan ta hian a ligands kha apoi mota ni heta hian FeCN6 kan neya CN hi spectrochemical series atanga kanen khan strong ligands ani chuwang chuan strong ligands ani awang khan it will cause the splitting to a large degree more helai splitting hi na satakin a cause don ani larger splitting more strong field ligands larger splitting ani kha chuwang chuan helai hi a splitting kha anasat chuan delta O value kha asang don ani the magnitude of delta O will be large helai inkar hi azau dona chuwang chuan electrons kha they will tend to remain in the lower set a lower set a khan an omang achunga khan an zuang chho zung thailo tina ni chuwang chuan paruk kan nei ta 1 2 3 4 5 6 fill up tur kan la nei kha achunga chholo khan anwaya pairing om don ani achan chu CN kha strong ligand ani wang khan helai splitting hi a cause na sa a splitting ana sat kha chuan magnitude of delta O helai inkar value kha a large dona mo a large a chuwang chuan electrons kha an zuang chho thailo ani chuwang chuan pathum la bang kha they will tend to remain in the lower set more 3 paired electrons kan nei ta ni chuan so in the presence of strong field ligand CN in this compound the number of unpaired electrons is equal to 0 unpaired electron kha pakhat ma om talaw ani chu mom misha thiamem However, in the second compound hian H2O hi weak field ligands anitani. Chu wang chuan splitting kha cause na salawanga magnitude of delta O po kha a small don ani. Chuan iron ani le a central metal atom chu argon 3d6 4s2. Again, iron is in +2 oxidation state. So we have 6 electrons in 3D. Chuan 6 electrons sa omanga tahian 1, 2, 3, 4, 5. 5d orbitals ka. Mo. 1, 2, 3, 4, 5, 6. 6 electrons kan nei tani. Chuan crystal field splitting ka aron ta a. Hilai in kar hi crystal field splitting energy ka delta O kha. Mo. T2G seta orbital pathum EG seta orbital panhi kan nei le tani. Chuan tahian 6 electrons anita a kan nei hi kan fill up tur hi. H2O hi weak field ligand ani. Weak field ligand ani awang khan it will cause smaller degree of splitting. Splitting kha helai kar splitting kha a cause na salawani chu. Chu wang chuan crystal field splitting energy value hi a small don ani. Helai in kar hi a zim don tina ni chu. Chu wang chuan electrons po kha hetan chuk theya hetan an chho zung thei don tina ni chu. Electrons can easily jump from lower set to higher set. Chuan paruk kan ti kha mo 3d6 ani wang khan 1, 2, 3 pathum la oma kha achunga kan ti photang 4, 5 anita a paruk na kha anwaya kan perang mo kan pairing kha kan ti chan le ta chiani 1, 2, 3, 4, 5, 6 electrons kan fill up ta chuan khatia kan fill up nu khan number of unpaired electrons kan zonga number of unpaired electrons will be equal to heichia hi paired ani wang khan 1, 2, 3, 4. So the number of unpaired electrons in this compound is 4 due to the presence of weak field ligand H2O, which causes smaller degree of splitting, hence delta O value is small. So electron can easily jump from lower set to higher set. Alright. Chuan heta compound panhi karon pe ka hian unpaired electrons zat kha crystal field theory mangin kan zonga FeCN64- a unpaired electrons sa omlawa FeH2O6 2 plus ion a chuan unpaired electron kha palia omtina ni chu. Chuan crystal field theory mang khan problem pakhat kan solve ang. Determine the number of unpaired electron in Fe3+ using crystal field theory in the presence of number 1 strong field ligand, number 2 weak field ligand. Alright. Pakhat na hi kan ti masang. Heta hian Fe3+ a hian unpaired electron engzange crystal field theory mangin kan zong don. Pakhat na chuan strong field ligand na. Panhina chuan weak field ligand na ni tani. Chuan strong field ligand na chuan Fe3+ kan ti phot don tani. Heta hian electronic configuration kha ama sabera kan ziak leang. 3d 4s2 3d6 ani kha. Fe here +3 oxidation state ta oma wangin. It involves the loss of 3 electrons. Electrons pathum kan pai dona a satangin kan pai photanga alabang zong kha d atangin kan payang. So 4s 0 ania pathum payanga angaya wangin 3d tangin pakhat kan pai lenga 3d 5 along ni don ni. Mo chuan heta hian 5d orbitals kha degenerate 5d orbitals kha kan siam le a 1 2, 3, 4, 5. 5 electrons kan nei ta ni. Chuan crystal field splitting alo oma. Lower set le higher set. Hi T2G set kanya. Hi EG set. Chuan energy difference ka delta O mo. Chuan ta hian in the presence of strong field ligand ania wangin. Strong field ligand ka chuan helai in car splitting ka a cause na satani splitting ka tina sa ana sa chuan crystal field splitting energy delta O value hi a large don tani helai in car hi azau ta duai don tinani chu chuan ta hian 5 electrons kan nei hau kha 1 2 3 kan fill up phota adang pahni kha helai in car hi azawa wang khan higher energy level a khan ankai chho thei mai lo so they will try to remain in the lower set anwaya khan an umta kan fill up ta 1 2 3 4 5 more chuan chuti lo ni chuan number of unpaired electrons chu 1 chau tina ni ta alo ni ta ni chu. Alright, so in the presence of strong field ligand in this compound, the number of unpaired electrons is 1. Chuan weak field ligand a ve thung kan lo enanga Fe electronic configuration kan ziak le photang. Chuan Fe 3+ ion ani wang khan. Again, it involves the loss of 3 electrons. 3d5 alo ni ta. Chuan d a 5 orbitals a khan 5 electrons kan lo da le anga 1 2 3 4 5 more 5 electrons kan lo da le ta. Chuan crystal field splitting kha lo om le ta ni. Chuan 5 electrons kan nei kan ti kha hei hi in the presence of weak field ligand ani awang khan weak field ligand kha chuan helai splitting kha a cause na salawani chu wang chuan delta O value kha a small don ani a in kar azim don ani chu hemi le hemin kar kha azimanga electrons kha anwaya tangin achunga ol sam takin anzuang chho thei don ani. So 5 electrons kan neya 1 2 3 4 5 achungan zuang chhotani. So in the presence of weak field ligands the number of unpaired electrons is equal to 1 2 3 4 5 5. We have 5 unpaired electrons in the presence of weak field ligands. Chuan khang zong kha crystal field theory manga kan hanzir thei tlang pui te chu ani em.